All right, so today we're going to be working on a board that's really, really nasty. So to give you an idea over here in the microscope, here's what our really nasty board looks like. As you can see, it's really nasty. So the current sensing resistors for both the battery and the charging circuit are fucked. I'm going to take a wild guess that the charging circuit is also fucked. And we're just going to be doing one of the things that I like to do when something looks like this, which is starting over from scratch. There's no way in hell I'm leaving any of this stuff here and expecting that any of it actually work. That would be silly of me. So, yeah. Now what I'm hoping for is that I can reuse a lot of these probe points. So what I'm talking about when I say probe points here is right over here. So these are current sensing resistors. So the whole idea here is this over here is where the charger goes through, right? So the charger comes through this thing with the hair and the fuzz and the nasty shit on it, because most people, with their computers are nasty. And so there's going to be a very small voltage drop across that resistor. So on the top and the bottom of that resistor, you have these resistors going here. And the whole idea is this, on this point and on this point, this chip that you can't see because I'm out of focus. All right, back to where we're supposed to be. So the way this is going to work is that this big green resistor I showed you, now the top of it is coming in through here, and the bottom of it is coming in through here. And there's going to be a really small voltage difference between these 2 points, and that chip is going to use that voltage difference to determine the amperage use of the computer. You could read on how high-side current sensing works if you're interested, but this is the circuit, and as you can see, it looks pretty nasty. Those 2 resistors are supposed to be 10 ohms. I've measured them, but I wouldn't need to measure them to tell you that they're nasty. And there's a bunch of liquid there. So I'm actually working backwards at this point. Knowing that I'm going to have to do all this work anyway, that's going to require ultrasonicking to make it not look like shit, I'm going ahead and actually replacing these things and running all my wires, and then I'm going to dump it in the cleaner. So at the very least, there's a chance of me having less cleaning steps involved. So that's the ISL6259. These current sensing resistors are done for. That capacitor between them is done for. Those 2 are done for. Now what I want to do at this point is I want to go around the area with some flux in my iron and see just how much of it is actually ruined. Like, do I have to run wires, or can I get away with what's on the board? You want to get rid of the oxidation, you want to get rid of the junk and the nasty looking rusty shit, but you don't want to get rid of the probe points where you can actually solder to. So what I do is I put flux on there, and I'm going to run this leaded solder ball over that area, and after it gets nice and hot, I'm going to gently touch the iron like that against the board, but I'm going to wait until the hot solder ball is kind of, with the flux, has gotten away a lot of the nasty shit. It kind of backfired on me there. See how my capacitor moved? We'll put that back in a moment. And I kind of destroyed that thing over there. But I don't care, because I can grab that off of a donor board. If you don't have a donor board, then you really should care about these things. I don't want to scrape too hard. First, I want to go around with the big solder ball with a lot of flux. And then once I'm confident that it's had enough time and it's hot, and then I can gently scrape. It allows me to rebuild my pieces over here, or the things that I need. Alrighty. Looking a little bit better. Looking a lot better, actually. So a lot of my broken connections are almost broken connections are kind of healed at this point. And I'm ready to go. Now, am I going to go? Here's the thing: even if you buy those components new, I have a lot of things to, little things to replace. So if I go through on a board, if I go through a bunch of component bins to get all those components from, it's going to be a nightmare first. I'm pulling a 10 ohm resistor, then I pull another 10 ohm resistor, then I pull a 0 ohm resistor, then I pull this capacitor, then I pull a 2.2 ohm resistor. It's really a waste of fucking time. So what I like to do is I like to find a board that has those pieces on it and just take them. Because keep in mind, if you're getting these boards for 15 or 35 bucks, and you're charging between $200 and $400 because the product itself is worth $700 to $3,000, it really makes sense to get your efficiency up by doing this in a more streamlined fashion. And the streamlined fashion is going to come from efficiency, from just having the fully assembled boards available for you to take things from. Okay, so let's start with the steeling process. That bottom resistor is a beautiful 10 ohms. I measured it before putting it there. See how I don't give a crap about aligning it perfectly? Because surface tension will just make it align itself. See how when I touch it, it kind of moves around? I'm doing this to prove a point here. It moves itself into place. Now, that's not perfect. So if you're trying to get it perfect, you may realize that you spend a lot of time trying to get it perfect if you're a beginner, and you can't get it perfect. And what I'm trying to get you to realize here is even if you can't get it perfect, don't care. Surface tension will get it into place, and then you can clean up whatever is a mess at the end. Pretty simply. Some nice Amtech 559 flux and a curvy tip allows me to be somebody who is really not good at aligning things and kind of get away with it. I'm touching every tip there, every point. One of the things you have to realize is that you can think it's soldered from this angle, but when you look at it at a different angle like this, it tells a different story. So as a beginner, it may be a cool tool to have a microscope and a little thing that put the motherboard on a stand that lets you solder at an angle. It may help you. You may find that that helps you as a newbie. I wish somebody had mentioned that advice to me a long time ago. There was a time when I knew through-hole soldering great. I wasn't at surface mount. Oh, no. Clueless. And one of the important things with surface mount soldering is that you have your thing flat on the board. So see how some solder balls popped out from the bottom? That's because even though surface tension snapped it into place, it wasn't flat on the board. Then once the surface tension gives me my alignment, once I know that my alignment is right, then I'm okay with pushing it down on the board. So first I just want to get the alignment right. So I just let surface tension get it into place even if it's not soldered perfectly. Then I get my alignment right, and once my alignment's right, I just push it down and just clean. Curvy tip. Having the chip flat on the board is important. This is one of the things I noticed at Practical Board Repair School. If you want information, we are actually teaching a class on this. Check the description and the video for more information on what it is. A lot of people were confused as to why their connectors just weren't soldering, and a lot of people were soldering the connectors not flat on the motherboard. Like that thing has to really be hugging the board in order for it to work. This is these basic principles. You can be as clean as you want. You can be 10 times cleaner than me, and ain't shit gonna work if you're not just, flat. So I have nice probe points, nice connections, and with the flux in there, after I put the flux in hot air, it actually moves everything back into place for me. So that when I ultrasonic this, it will actually have a little bit of a stock feel to it. Like it's not going to look like somebody with the world's shittiest hands actually went in and placed that resistor and then that one and that one and then aligned this chip and its 28 connections. Again, I use surface tension to get this thing snapped into place. Once it's snapped into place, I heat it and I push it down. Do not worry about these superficial marks. Does it matter if you stab through the chip? Absolutely. On this particular chip, can you push down a little bit and not care about the superficial mark? In there, yeah, who cares? It's funny that I actually put the stab through my last initial. I'm curious if that's some kind of subconscious thing. So now I know over here this is supposed to be a 0 ohm resistor. This is for feedbacks. Let me just check and make sure that that is actually 0 ohms, because that commonly goes bad. I can't keep my hands steady enough for it to actually get a good reading. Okay, 0 ohms. There we go. So now I don't expect the fan to spin because, again, I haven't even ultrasonic this yet. But I just want to see if I've made progress. And we also have some issues by the TPS 51125 circuit over here for 5 volts. That's nasty. That is nasty. So let's just... a little bit of Amtech 559 over here. And before the ultrasonic, before we go nuts, I'm pretty sure that chip is fucked in some way, but let's just see what this does to get rid of the corrosion. Flux and heat is a great way to get rid of corrosion. All right. Again, I'm pretty sure we're going to have additional problems, so don't get all excited just yet. I don't expect to see a fan spin, but I just want to see if I've made any progress. This was 100% dead, no light, no nothing, 0 volts, and let's see if I have anything better than that. So I have a green light, but the fan's not spinning. So the thing with the green light, see what that tells me is that I've made some progress. It also tells me there's a chance that my SMC is actually good. The other problem here is I have 0 volts on PP bus G3 hot. Okay, so that's not really giving me the enthusiasm that I want here. So a perfect 0 volts on PP bus G3 hot would be most likely caused by some type of short. So let's see if there's a short circuit. And what do you know? There's a dead short circuit to ground. And my TPS 51125 looks like shit. Let's see if those two are interrelated. Now here's the thing here. One of the things you have to realize is that U7200, this chip over here, this where it controls a buck converter. So this chip, when you look it up in the schematic, is going to control a buck converter. So if I take this off, that buck converter is going to be pretty much on all the time. So it's going to be, instead of it switching to make 5 volts, it's going to allow 12 volts to the transistor all the time, which is akin to destroying it. So you're going to send 12 volts to everything on the machine that was expecting 5, and at that point you can take your board and say bye-bye. So I'm going to remove that and replace it, but hell no am I going to plug the board in without a buck controller IC present. Really, Windows? Is noise that loud absolutely required? Well. Okay. I'm going to wind up replacing that fan connector because I've been mean to it. Well, aren't I on a fucking roll today? I can't get my hand to stay closed. Okay. I have a bridge. And my air was way too high. I don't know if you noticed that, but... I'm so used to this thing happening with the FR801 where the red light goes off and the heat goes off. So if you have too much heat and too little air, the red light goes off. So what I've been doing lately, because I get tired of that shit, is I have the air up to like 20 all the time, which is obviously the wrong way to operate this. But it's just one thing that I do. So I'm hoping that my short was in TPS 51125 or in that capacitor that looked nasty, because I don't feel like hunting for it at 7:59 p.m. But I'm pretty sure I'm going to have to go hunting for the short at 7:59 p.m. because that is the way the world works. And that is indeed the way the world works. So let's see. Do I have 12 volts now or still 0? I have 0. So what we're going to do now is take my power supply and do the most fun thing there is to do here, which is send a nice spike of 12 volts. Well, not 12 volts. We're going to start at something like 0.5 and go up from there. And see what gets hot. Current, I never limit. You limit current by lowering voltage. Now, time to see what gets hot. Is it CPU FETs? Okay, so it's not CPU FETs, and we've turned this up a fair amount, and man, what could it be? Okay, so 7 volts at 10 amps. That, whatever that is, that would be something that should be very obvious. And it seems like it's the actual ISL6259 itself. Seriously? Let's see what's going on here. So let's see. This is soldered on with the proper orientation. But I'm open to the idea that I've really done something very, very wrong. So if I remove the ISL, what happens to my short circuit? It's still there. Let's see what side of the fuse my short circuit is on. Or maybe let's just feel around. So that entire area of the board appears to be nasty. Or it could not. It could just be that the transistors on the bottom are actually what's the problem. So let's see. These are the transistors for the buck converter. Yeah, that's it. So it's actually heating the board all the way to the other side. Let's take those two off. Now here's one of the things that you need to realize when troubleshooting a buck converter circuit is that if one of those transistors is bad, you replace both of them, and then after you replace both of them, you replace the controller. You don't replace one and then the other and then the other, because one being bad and being shorted will happen to kill the rest. So we take those two off, and I'm going to take a new ISL to replace the ISL that I put there. We're not going to reuse that ISL. By the way, trying to order those transistors is a complete nightmare. You just need to have a source for the boards. It's not like you go to mouser.com and they're going to be waiting there for you. I'm going to chase that little solder ball and catch it. GTFO. And I'm going to clean that other one with flux in a second. A lot of people criticize my work and say that the way that I solder, if I were on an assembly line, I would be fired. I would never even get to the point of being accepted onto the assembly line because of this. And one of the counter arguments, I shouldn't even say argument because I wouldn't say that I'm necessarily arguing with these people. When you're arguing, you're trying to convince somebody of something, and I don't really feel like I'm trying to convince them of shit, but I digress. One of the arguments that I would propose is that I hope over the course of my life that I'm never working on an assembly line. So one of the things about electronics in this business is the people who figure out problems on confusing circuit boards using their brain make really good money. And the people who sit on an assembly line, simply like placing components together or on a rework line as fast as they can, make really shitty salaries. Like, I mean, I'm talking as shitty as the salaries that you would get as an assistant manager at a fucking McDonald's. Like, that's what you're looking at to be a soldering station operator. So I understand that my soldering is not the best, and I'm never going to tell you that it is. That's why in all these videos I mention it. I know there are some things I could do to increase my, just make better even within the confines of my limited ability to control my hands, but I don't because I know that it would be a waste of time because I know that I'm never going to be the best because of those limitations. And one of the things is, again, if you are aspiring to be, or somebody who just does rework all day, what you need to understand is that the people who do those jobs get really crappy pay. And you want to be making money telling the guy with the crappy pay what to do. You don't want to be the actual person sitting on the assembly line. I don't want to insult people who make a living doing something. I really don't, and I really feel like shit saying things like this. The only reason I'm saying it is to get a point across. But there is not a lot of pride at being the person who sits in a little line and runs this little wire to this little place. If you're watching this channel, that's not what I aspire for you. What I want of you is I want you to be the person finding the flaws in these products before Apple does. I want you to be the person who figures out, why a certain machine is failing. When everybody else thinks it's the GPU, you figure out that it's something else. I want you guys to be better than that, and that I don't want you to be just a reworker. Like, it would depress me to know that somebody watched over 100 hours of these videos and that they went to some plant where all you do all fucking day is solder. That's not, again, that's not the point here. The point here is financial independence and respect and making good money in business through using your brain to do things that other people tell you is not possible. So, is it important to know how to solder properly? I think it is. But am I going to sit here and really care about the people who bitch about it? Especially when I get those comments where people are like, I get these messages. I'm like, I have been a professional rework operator at this company for 17 years. And I'll do some type of informational interview with them, or I'll call them and I'll ask them certain questions. And one of the things that I realize, because sometimes most of the time I'm really dead busy, but sometimes I do actually have the free time to do shit like this. I'll call, and it's like that position that you're talking about that you've been in for 15 years is like $14 or $15 an hour. I know that if I'm working at a company for 15 fucking years, I don't want to be making no $15 an hour. Hell no. And you know, it's like, okay, I get it. You've been doing that for 15 years. And I'm not saying that you should not be proud of your job, because there are a lot of reasons that you're going to be in your job in that place in your life. I'm not saying that you should feel shame for, you should never feel shame for doing what you got to do to put food on the table for your family. My dad had took a bunch of really shitty jobs when he needed to, just so that we'd be able to live indoors. And you should, he said, I would pump gas for my family. That's something to take pride in. But if you're going to go on, if you're going to go on some huge tirade, some huge rant where you're like putting people down, and you're like, I've been doing this thing for 15 years. When you're putting me down, I'm not saying like basic criticism. I mean like, you should never be allowed to do this. You're an idiot, blah, blah, blah. What you need to realize is you should have you don't have the right to be on that high horse if you've been working 15 years at a job that pays you $14 an hour. Am I going to say that you should be shameful for doing what you need to do to put food on the table for your family? I would never say that. But what I will say is that you definitely don't have the right to be judging me with that type of vitriol. You just don't. But anyway, I'm just rambling for the sake of rambling. It'd probably be better off if I had you listening to the damn air filter than to me. Isotope RX4 is really good at getting rid of the air filter. Eventually, I'm sure by popular demand, they will make a plugin that cancels out my complaints. Okay, remember what I said. Chip's got to be flat on the board. If it ain't flat on the board, it's worthless. Ay, ay, ay. Okay, so now we're going to take this board. Let's see if the short is still present. The short is gone. So when I have this power supply set to 10 volts, it's delivering 0.002 amps, which gives me some confidence that when I plug the fan in, and when I plug the MagSafe in, that I'm going to see a fan spin. Now, once that's done, what I'm going to do is I'm going to clean off the board. I'm going to make sure it works. Then we're going to put the board in the ultrasonic cleaner, and I want to show you what it is it looks like at the end, what type of result you can get. But first, that will require me making it turn on, which we're not at that point just yet. So let's see. So we have a green light, and let's see what voltage I get on the fuse. I get 0.2, which is complete crap. All right, so let's see. What do I get elsewhere on the board? Yeah, 0.2, aka junk. Nothing's being let through. So Let's just see if this has the capability to turn on. So if I have the charger plugged in and I apply 12.6 volts, I have a fan spinning. Now let's talk about why this is important. This is an important one. So what I'm doing over here, again, I have a green light in my charger and my short circuit is gone. And here's the machine, it's off, but when I put the on button on my power supply, it spins and it turns on. This tells me that a lot of the rest of the systems in the machine are okay. My SO rails, for the most part, are probably fine. Again, I don't have shorts to ground on all my major power rails that I'm going to really care about. This tells me that most of my job is done. So now, what I get out of this whole, what I take away from seeing that and seeing 0.2 volts on my fuse and seeing 0.2 volts at most places on the board, what I take away from that is that my charger power is not being let through, and that could be for a number of reasons. So what I want to do now is I want to see where is it that my charger power has stopped. So what I'm going to do over here is I'm going to open up the schematic so that it can show you a little bit of what's going on and what I've done so far on the 820-3115 board. I'm also going to make sure that I have enough disk space left to continue the recording. So I have 87 gigabytes, which is really pushing it since I record this at x264 QP equals 1. So I might just have to delete some stuff or hurry the fuck up with this one. So anyway, let's go over to the board view software here. Let's show you what it is I'm talking about. So U7000. So this circuit is what takes this buck converter. If you don't know what a buck converter is, please watch one of my many, many other videos on the topic. It takes the 16.5 volts from the charger. First thing that happens is that these two transistors are going to let the charger power in. Once the charger power is allowed in, then these two are going to blink on and off, on and off, on and off, and the combination of 16 and 0 and 16 and 0 is going to average out until it becomes 12. And then this inductor, which it can only pass DC, which is flat, is going to kind of flatten it out. And this capacitor over here, which can only pass AC going to ground, is going to get rid of some of the ripple voltage, some of that AC, but it's also going to act as a battery. And this is going to send 12.6 volts to the rest of the system. Now, what we replaced were these current sensing resistors. We also replaced these current sensing resistors. We replaced this chip. That was a big part of what was wrong. And now what I want to see is where does the charger power stop? So does anything come in over here from the adapter? So where does charger power stop? So let's measure at a few different points. So one of the points I'm going to measure at is the actual DC in fuse at the top of the machine, and I want to see if I have 16 volts. I have 16 volts. And obviously I have to have had 16 volts there because I have PP3V42, which is required for the green light to turn on. Again, I'm starting to go into advanced concepts here and not explain them in real time. If you want to know how I know that I have PP3V42 because the green light is there, look at my one-wire circuit videos. So I want to see where the power is actually stopping. And it's actually not even stopping over here. So right over here at this particular point, over here, I actually have 16 volts. But the problem is that this is not pulsing. It's not making the pulses that it's supposed to. So this chip is not really doing its job. And now I have to figure out why this thing is not doing its job. And that's going to suck. Is it that the transistors I soldered on got burned? Is it that I took those transistors off of a bad donor board? It could be a number of different things, but my problem is kind of over here. So now I'm going to want to check a lot of the standard things over here. I'm going to want to check over here, the VDD and the VDD-P pins to make sure that it's getting 5.1 volts. I'm going to want to make sure that U7000 is receiving power on the DC in pin. And we're going to go over all these little things because there are so many things that could be missed on a board that's as corroded as this one. So it's going to be important to get a little bit more context. So now we're going to switch back over to the board. I'm going to measure at a few really important points. So one of the things I'm going to want to see. All right, so by D7005. So over here, what do I have on pins 1, 2, and 3? What do I have on R7005? What do I have on all this stuff? $16, $16, $16, $16, Oh, I hate when nothing is wrong. Okay, let's blow some of that flux away. That's making it there. So this is interesting. Over here I have 5 volts, but over here I have 3. So let's see what's going on over there, because I'm pretty sure that there's supposed to be 5 volts on both sides of that. So I'm going to take a guess that it's R7001 from memory. Let's see what R7001 is going to be. I'm pretty sure. Let me just open the proper board view. This is a board view for a different board that I was working on earlier. That is R7001, and that's over here. So on one side of R7001, it's less than it should be. I wonder if R7001 is actually 4.7 ohms right now. And the pin that's bad is pin 2. So let's see what C7001 looks like. I'm pretty sure that's going to be located nearby. Maybe C7001 is bad. Or R7. Let's take a look here and see. I'm pretty sure that resistor is good because it's a resistor that I actually replaced. But I have trust for nothing. Especially what comes off of these donor boards. So that resistor that's supposed to measure almost very little resistance is measuring 4.18 kiloohms. So that resistor, R7001, is supposed to measure 4.7 ohms. And this, again, 4.7 ohms is what that's supposed to be. And it just so happens to be 4.7 kiloohms. Now, here's the part that's really stupid and fucked up. All right? So I measure this stuff before I take it off the donor board. I'm expecting it to be 4.7 ohms, right? So when I put the probes in the multimeter there really quickly and I see 4.7 show up in the multimeter, I didn't check to see that it was kiloohms. I thought it was ohms because that's what I was expecting to see 4.7. What the fuck is the likelihood that the resistor I'm taking off of the donor board, that's bad? Not only is it bad, but it's bad to 100 times the resistance that I needed. Actually, 1,000 times. Yeah, because 4.7 of 4,700. Where's my brain? So not only is the resistor bad, but it's bad in a multiple of 100 mathematically. You can't make this shit up. This is why I record this again. Like this is dumb. I feel dumb sometimes. So back to work. We're going to remove that resistor, and just in case that cap is shorting anything to ground, you get to go as well, mofo. You can't make this shit up. That cap was stuck on the board, which you know what that leads me to believe. Okay. We take the iron. It's going to beep eventually, which means that it's hot enough to melt solder. Now we're going to measure the resistor this time before stealing it. Good. Fucking piece of shit, man. Fucking piece of shit donor board. So as I said, I take components off donor boards to save time, and of course in the video where I'm talking about why it saves time, it's a video where the donor resistor I take off is bad and waste time. But most of the time it saves time. The amount of time that I've saved not having to go through a bunch of spools to find 15 different pieces to replace around the chip, I still support using donor boards. Okay. Now I'm going to plug the charger in. And let's see if I have a fan spin. Let's see if I've graduated. So when I plug this in, I still have the power supply connected, so it should tell me voltage in a second. 0.2. Boo. All right, so we still have some things to go about looking up here. Let's at least continue my measuring. That's up to 5 at least now. We have 5 volts on both sides, which is more than I could say for before. Something's funny here. Same shit. Improperly soldered, maybe? Wouldn't put that past me. Left side is good, bottom side sucks. Right side is good. Top 2 pins could be nicer. Top side looks good. Yep, bad ISL soldering, so I suck. Anyway, so let's take... So it really does have to be flat on the board. So fan is spinning, and here, power supply off. All right, so yeah, well, the reason I was stuck at 0.2 was two reasons. The first reason was that R7001 was stuck at 4.7 kilo ohms instead of 47 ohms, and also the ISL was soldered badly. As I said, again, I realize my soldering sucks. I don't need you people to tell me. I get that. And I totally, I've never claimed to be the world's greatest solderer. In fact, I think in every single one of these videos, I make sure to say that I'm an awful solderer. But one of the things that I hope you can learn from me is that one of the things that you should do when inspecting your work, and this is another thing that I noticed, so at the practical board repair school that Jess is doing, she's having me as one of the professors for the time being, and one of the things here, again, this is the important thing, a lot of people were looking at their work, wondering why it didn't work straight on. And the thing is, you can't see the joints on a QFN chip without looking at it at an angle. You can't look at the top of it because, yeah, so this is attaching to this, right? So how are you going to see that when you're looking at it like this? You're never going to see the connection. You need to look like this. So again, one of the things that's nice about this microscope, this is the Omano 2300S, is instead of having one with the Omano 1030, this is one of the reasons why this is really cooler than the Omano 1030, is every time I wanted to do that, I had to walk back here, unscrew it, bring it up, and if I wanted to look at it at an angle. Or what I would do is I would pull the microscope out of my desk and then look at the board at an angle on the table. What makes it easy with this is I just go like this, and I can do it. Then when I want to go back down, I do this. The articulating arm drives me nuts because it lacks stability. If I move, like again, here, look. Like if I'm just wheeling myself around the room, so let's say this thing shakes for seconds. It's annoying like that. But one of the things that's cool about the articulating arm and the boom stand is that when it moves around like that, when I go up and down, it makes it easy to check the side of the chip and inspect my work. So a lot of what I'm trying to teach you here is not just how to do a job perfectly, but it's also when you have imperfect situations, when you're imperfect yourself, how it is you can check yourself. So one of the signs of a professional, it's not always that you hit, it's not just doing a job the professional way, meaning you do everything perfect. It's when you screw up, do you actually give up at the point of screw up, or do you figure it out so that you can get the job done properly? Professionals, it doesn't matter if it's 1 in the morning and you're tired. It doesn't matter if there's one personal flaw that you have that doesn't make you good at your job. What matters is that at the end of the day, you can consistently put out product that works. And again, that's one of the reasons I just don't listen to the trolls on that. You know, I consistently put out product that works, which is more than I can say for a lot of other people, and I can live with that. So again, if you have issues soldering the ISL chip, again, I made this mistake in front of you in real time. I told you, have the chip flat on the board. Make sure the chip is laying flat on the fucking board. And did I have the chip laying flat on the board? No, not at all. And this is why, like, you know, you see all these videos on YouTube on how to do things like this, and what you see is people hiding and hyper editing and editing out all the little things because they want to seem perfect. And it's not about seeming perfect. It's about when something doesn't go the way you want, can you get it to go the way you want anyway? Will you catch your mistake? The sign of a professional is not making mistakes. It's catching them. And that's that. Again, what I'm going to do here, so I'm going to put the board through the ultrasonic cleaner, and I want you to see what it actually looks like afterwards, because right now it's a mess of flux and crap. So you saw the before. You saw how all those pads were nasty and destroyed and fucked up looking before. What I want you to do is I want you to see the after. So you're going to see that next.